Hello everyone and welcome to our webinar on Tux Magic Hat, analyzing AWS Flow Logs for fun. I'm Nandini Bharadwaj, the operating officer at CyberWarFare Labs, and I'm excited to have you all here with us today. So let's get started. So before we start, let me tell you a bit about us. We are CyberWarFare Labs, a UK-based company focused on cybersecurity education. Our goal is to help people tackle cybersecurity challenges with practical solutions. Here we have got two main divisions to our company. The first is Cyber Range Lab. So this is where we get hands-on experience with cybersecurity. We have built a virtual platform where you can try out real-life scenarios and sharpen your skills with practical exercise. And the second one is upskilling platform. Here we offer a bunch of courses for people at all skills level. Whether you are starting out or you are a seasoned pro, we have got something for you. Our courses covers domains like ethical hacking, red teaming, blue teaming, purple teaming and cloud security. And recently we have launched our new learning platform that is Infinity Learning. There you can just sign up for free and our training services are also available to educational institute, government agencies and corporate organization. Both online and offline training options are available. If you want to know more, you can drop a email to our support team, that is support@cyberwarfare.live. Okay, so let's move to next slide. So let me introduce to our speakers of today webinar, that is Abhijit Kumar. So Abhijit is a security researcher with an expertise in red team operation, network security, cloud infrastructure, and Linux systems. He is also passionate about researching adversarial tactics, techniques, and procedure, and frequently experiments in his home lab. So we are excited to hear his insights today. So that's all about the speaker. And dear participants, as promised, we are excited to share that you will receive your attendance certificate within next 48 hours, along with the video recordings of the webinar. And candidates who have participated and shared the feedback link of Infinity platform on our support team, that is support@cyberwarfare.live, will get the access of our popular course, that is Purple Teaming Fundamentals, for free. So if anyone who haven't participated in the giveaway until now still has a chance to get the PTF course for free. So what I'll do, I'll send the link to the text box on your text box and you can just follow the steps to win. So yeah, thank you for being the part of webinar and we look forward for your continued participation. And here without further ado, I would like Abhijit to take over.
Hello, is my screen visible?
Yes, Abhijit, your screen is visible.
So let's move. So let's first welcome folks. Thanks for joining our webinar. Let's first start with the basic introduction. So typically this is something that AWS offers. And before diving into that, let's see what AWS is. So AWS is the Amazon Web Services, and it has a very good product catalog of approximately 230 to 40 or even more services which come across various domains like compute, serverless, AI/ML, and many more. And one of the good things about this is AWS is one of the oldest cloud providers, and it has some very good logging options. So you can typically um, log everything that is going on inside your AWS environment, and it is kind of very native services that are offered by the AWS to log and analyze those logs. Now moving on, VPC is a component in AWS, which is a virtual private cloud inside which you have various different networking components which are isolated for each customer. So you can assume it as a namespace within your own environment. So it is your own, and you can create multiple resources inside it. And some of these resources or components are subnets, routing, IP addressing, gateways, and endpoints. So I'm assuming that you guys have at least some beginner level understanding of IP addressing and network components. So focus of this is the VPC flow logs, which is something that is offered by the AWS, where you can capture the logs. And this is a typical example of a VPC. So you can see like this is your VPC on the left side, and then we have the different subnets. Some of these are public subnets, some of these are private subnets. So in private subnet, it is something that is not accessible from the internet, and the public subnet is something where um, it is accessible, the services are exposed to the internet, and furthermore it can be configured or it can be locked down by using the security groups and other settings. Next is the routing table, which is kind of the routing table that we know in networking. It maps different IP ranges, and it acts as a translator, or it acts as a dictionary for connecting from one network to another. And then there are the network connections, which are endpoints or gateways which allow you to connect to different networks. So imagine you have two different VPCs, you want to interconnect them without, let's say, using any um, public access or something. So you can configure it that way. Now, VPC flow logs. So these VPC flow logs are pretty much metadata service. They operate on both ingress and egress. Ingress is your traffic that is incoming, and egress is the traffic that is going outside. And it is a very good way to kind of monitor your traffic that is coming to your VPC or whatever resources you have configured it for. And one of the best things about this flow logs is the data collection is agentless. So you do not need to install any agent on your machines or your VMs or in your VPC to collect this data, because it is agentless. It is configured, it collects data, and it is passive. So um, if you are installing agent, that is kind of an active kind of monitoring, but since this is captured by the AWS at your boundary, um, whatever level you are capturing, we will be touching the levels in a bit um, in few minutes. So anyway, so some of the common use cases for this VPC flow logs is you can use it for the diagnostics. Let's say if you are having some issues connecting to the outside networks, or if you are having some network connectivity issues, you can debug it using the flow logs. You can also perform some sort of intrusion detection or anomaly detection based on these flow logs, because they will give you a very good understanding or very good insights about whatever traffic is coming into your resources or going out from your resources. And some of the pros and cons of this VPC flow logs we will be seeing in couple slides. So one of the very first pros is there is no impact on the network latency because this is agentless. So it is collected by the AWS at whatever boundaries we have set, and that is why like you do not need to worry about any latencies, because it is flowing and it is just capturing at the gateway. But one of the cons of this is once you configured a flow log, so you cannot change it. So let's say if you added some of the fields, and we will also be touching fields in a bit of time. So let's say you configured some of the fields. Let's say you forgot to add the destination port. Now you have to create another flow log for that, because once configured, you cannot change any of the settings. Okay. Another pro is since it is a AWS based service, it is easily incredible. You can easily integrate it with the other AWS services, or even you can combine it with some of the other outside services by the third party providers. Now, moving on to the cons. So one of the cons for this is you cannot capture all type of traffics. So certain type of traffics are not captured by the flow logs, and these Traffic types are usually when you query the AWS metadata service, that is 169.254, 169.254. You cannot capture traffic to that IP address. And some other things are like you can capture traffic to the AWS's time servers. That is also on, I think, 169, 123 or something. And another one of the traffic types you cannot capture is when the requests are being made to the AWS's DNS servers. So if you want to capture the DNS level traffic, it has to be made to a server outside of AWS. Maybe it is a server you control, maybe it is a server controlled by some other vendors or providers. Now, another pro of this is you get very enriched metadata. So if we look into this metadata, it is a very much comprehensive. It captures very rich details, including instance, number of bytes, number, which port it is coming from, which is the source, which is the destination. Having said that, one of the cons is it is not real time. So by default, when you set up the flow logs, it will be by default a duration of 10 minutes. So the logs will be delivered per every 10 minutes to your wherever you have fixed the destination to. At the very least, you can configure it to be a 1 minute distance where you can see where you can kind of configure it to 1 minutes, and then the logs will be delivered to wherever you have stored it. Now that we have talked about these flow logs, some questions arise. First question is, who are these flow logs? And the second question is, where do these logs come from? Let's look into that. So this is an example of some of the fields we can attach to these flow logs. We can see there is account ID, there is action, which action was performed on this, whether it was allowed, whether it was denied, is it ID's number of bytes, what was the destination, and many more things. So you can see like this is a very enriched metadata which I had mentioned previously. Now these are very good, and this screenshot that you are doing seeing it is for the EC2 service only. Like this is for the EC2. Like if you're trying to capture the data for the ECS clusters, so there will be some other different fields that will be included which are not covered in this one. Now, capturing flow logs. So now we have talked about the flow logs, and now we'll try to answer the second question, which is, where do these logs come from? So, firstly, we can capture them at the network interface level. Now, let's try to visualize this. Let's say we have an EC2 instance in our VPC, and that instance has one network interface which is public and one network interface which is private. Let's say we want to monitor traffic for the interface that is public. So we can capture the traffic on that interface only. So in that case, this interface will be configured as the source from which the traffic will be captured, and then it will be delivered. So we are not monitoring the private interface in that case, and we are only monitoring the public interface which is publicly available. That is the first log capturing thing we can do. The second one is at the VPC subnet level. So let's say we have multiple subnets in our environment, in our inside our VPC, and let's say we have two subnets. One is private subnet, one is public subnet. And let's say inside public subnets there are tens or let's say 20 EC2 instances running. So it will be very hassle to capture the logs at each network interface level. So we can actually configure it at the subnet level. So let's say we configure it at the private, like at the public subnet level. So in that case, it will be capturing the traffic at the whole subnet level. So doesn't matter whatever configuration or whatever network interfaces these instances have, the data will be captured. Whether it is public, whether it is private, it will be captured and it will be sent to whatever location we want to send it. Now we have touched upon the interface or individual level. We have touched upon the VPC subnet level. But what if we require something more? Here is the solution. We can capture it at the entire VPC level. So in this entire VPC level, doesn't matter how many subnets, how many machines we have, whatever configurations they have, the traffic will be captured for the whole subnet level. Now, this has some benefits as well as some disadvantages. So let's look into the benefits first. So it is a very good logging service, and we will getting a very good understanding of whatever traffic is happening inside the subnet. But some of the things that can be pretty not concerning, but kind of a very dramatic is very large amount of data will be captured. Most of the data might not be of use. Let's say we have some private subnets, that data will also be captured. Let's say we have one very active internal server that is private, the data from that server will also be captured. So that is something that will happen if you are doing capturing at the whole VPC level. Anyways, moving on, let's see where we can send these logs to. So, in the beginning, I had mentioned that AWS has some very good ways to log the traffic, and monitoring and analysis is also performed by the native AWS services. So, one of the services that is most widely used for storing and analyzing these logs is AWS CloudWatch. So we can natively publish this log to the CloudWatch. We can analyze it from there. But if we want something, let's say more robust kind of thing, we can publish it to the data firehose, which was previously AWS Kinesis. Then we can send this log to S3, which is probably by far the cheapest and most affordable solution for most people, because CloudWatch and Data Firehose, they can be costly. And it can also be coupled with other services like AWS Athena for analyzing the logs. But again, it is costly. So anyways, like it depends upon the use case of the individual or the organization on what purpose they're using it for. So anyways, moving on to the flow logs analyzation. So this is a pretty simple diagram for the analysis of these flow logs. And if we look into this, so there is a data collection where we are collecting the data. Then after data collection, there comes the part where we are cleaning the data. Then there comes a part where we are converting data into a form with which we can work. Then once we have once we have converted data to a form that is analyzable, we perform the analysis. And once the analysis is performed, we obtain the result or whatever insights we are looking for from the data. Now, so this is something I want to bit focus a bit on. So, previously we had delivered a webinar on 8th of July, and during that webinar, a couple of the instances were used, and those instances were public. So, during those instances, there were a couple of the things that was the instances were public. They were up for 10 hours. The IPs were also published. They were also displayed during the webinar. So we captured the flow logs, and inside that thing, we captured the flow logs at a VPC level. Okay. Now here is a diagram. So you can see like there are three layers. First layer is the subnet level where the instances are kept. The another is the availability zone, and the other like outside boundary is the VPC. So as mentioned, we can capture at any of these levels. So if let's say if we want to capture at the instance level, we can just configure this flow log to capture from this level. If we want the subnet level, we can capture to the subnet, and we can simply publish the log to whatever. And again for the VPC. So in this case, what we did, we captured the logs at the whole VPC level. We published the logs to the S3 bucket, and after publishing the log to the S3 bucket, we've performed some analysis on it. Now, I'll just focus on what I did during the analysis phase. So first, when I downloaded the log files from S3, it was very huge. If I recall correctly, I had approximately, I think, 100 plus MBs of data. And in those data, there were a lot of files. If I recall correctly, there were, I think, 200 or 300 files, and those were compressed files. So I received the compressed files. Then there were some logs to be performed. So what I did was I started by filtering the ingress traffic. So what I did, I first moved all the files into a single directory. I unzipped them, I moved them to a single directory. So all the files, all the log files were in a single directory. And when you publish it to the S3, the files, and when you unzip them, like when you, they're by default the format of GZ. So when you do tar-exif, and they will be in the format of .log, whatever the name is, .log. So I got a bunch of files. I performed the cat on all the log files. So this star is the wildcard, the first before the first pipe operator. I'm filtering all the log. I'm catting all the log files, and I'm gripping for the ingress. So there are multiple fields inside the log file. So I grep for the ingress. Then I run the cat command because I wanted to copy only the IPs. So cut D is the delimiter. Delimiter, we can specify anything. I specified a blank space because there is a blank space between every of the fields. Then I cut the field 16, which was for the IP. It might change in the future if they decide to add, or if it might also change if you're not capturing all the data, because I was capturing everything that was available for the EC2. Now after that, I sorted all the IPs into a numerical order. I ran the unique command so that I'll only get the one iteration of each, and then I simply moved them to a file that was named ingress.unique.txt. Now something very interesting happened, and even though I was expecting bit of traffic, what happened next, I was surprised. Within the span of 10 hours, I had over 17k requests, and these are total requests, ingress plus egress. And out of these 17k requests, ingress was 13k requests in total. And when I did some analysis, when I filtered and I did some things, I received 3k plus unique IPs. I mean, that's a lot. And I mean, it was approximately, I think, 3300 or 3400 something. So after seeing this much of data, I was like, okay, let's write a quick script. I mean, what could go wrong by writing a script? Okay. And initially I thought it will be like 15-20 minutes. I'll write a quick script. And I did. So first iteration of the script was 15-20 lines in Python. And I ran it with the unique IPs. Happened some it happened, it started working. I was waiting, and after 65 minutes later, approximately 65-66 minutes later, I got the results. Now what I missed in that script was I configured it to be a single threaded, so I did not configure any multi-threading or anything. It was very simple script. It was 15-20 lines at most. So took a while. I'm sitting there, I'm watching. It's going, progressing, happen. Now well, after some time I wrote a better version of it. The script worked, it was good, and it worked. So now is the demo time, but I'm actually having some network technicalities. So please allow me 5 minutes, less than 5 minutes, while I sort the issue out, and then we'll be back with the demo and something I wrote that I'll show you. So appreciate your patience. So let's see, we were on the demo. Let's go for the demo. So I have prepared it. Demo. And before going to the demo, I'll show you a quick tool that I wrote for this. So I think I have to share the entire screen. Just give me 1 second. So this is a script I wrote, and I hope the screen is visible. Yes, it is. So I wrote this Python tool. It is the iteration with some of the other features, improved features, and it queries the IP Info's public APIs, and it fetches the data that we require for our demo. So let me reshare the screen with the, yeah. Let me check. Okay, screen is visible. So let's first see how these flow logs actually look like. And let's not do the cat, let's do the head, because cat will be too much data. So this is how your typical flow logs look like. This is the account ID, this is the action ID byte. So you can see like this is the account ID for which this flow log was captured. This is the action, which action was taken. This is the availability zone. Third one where this is hosted. Availability zone is kind of your fail safes inside which you can deploy different resources like subnets and your machines. Then this is the number of bytes that were um, captured, destination address, source address, and whatnot. So this is kind of a typical flow log, how it actually looks like um, when we see it in a decoded or decompressed format. Now, I already have actually the mm, data from this. So you can see like this is a lot of data. And if we do something like this, we can see like this is 3375 unique IPs. So what we are doing is we are catting this particular text file, which is the output from the IP info. And this is WCL is we are getting for the word counts. Now, some of the things we can do with this is once we get this sort of data from the IP info, what we can do it, let's say we want to figure some things out. Let's say we want to see how many requests are coming from a particular country. For example, let's say we want to see how many requests are coming from the China. Like how many unique IPs from China connected to this particular instance. 237. If we want to list how many, which IPs or which one connected, we can see, okay, this is the number of things that were connected. Now let's see if we want to see how many of these connected from, let's say, Google. How many like these host names had the Google in this. So we can see like a lot of these connected from the Google, lot of these IPs were owned by the Google. Now let's say we want to publish or we want to get the host names, because most of whatever these IPs are coming, most of these will have a host name assigned. And that is particularly the reason, because most of, and from what I found is most of these requests that came, a lot of requests were from internet research groups and search engines like Shodan, Census, and other research scanners like Palo Alto and many others. Like, and specifically internal like university projects, which are research groups focused on monitoring or capturing the internet traffic, ports, whatnot. Some came for hobbyist. Some of them were from very shady sites. I actually looked into one of the sites, and it was kind of not APT, but kind of it was just scanning a bunch of things, scanning, doing the port scanning and whatnot. So, anyways, we can also something do. So, most of these will have a host name attached. So, if we are going for that, let's say we want to get the host names, we do this, we will see whatever of these have a host name. We can see like one of these has this particular 2132 from something something. Now we get the host name. What we can do is we can do the cut. Again, we can go for the delimiters, and we can do the field too. So we can see, okay, this is this, but let's say we want to capture for this. Now if you're doing this, we can see, okay, this is scan server, shadow server, dynamic IP pools. Let's say we want to get only the host names. We can use this for cut for, and we can see like a lot of these have unused spaces and whatnot. And we will also see some of the other things. And let's say if we want to get how many of these are host names, something like this, we can do something again. We can go for the word counts. 1930 are the host names, but Let's say we want to do something like this. So now we are shorting it, and let's say we again want to get the word count 1625, and we can see like most of these are from the mirrors and analyzation websites. We can see like internet measurement, we can see Shodan, we can see census scanner, and a lot of these things, but it is a fun thing to do. Anyways, moving on to the tool, I'll just show you a quick demo of it. So let me do one quick thing. Okay, so we can see bunch of IPs are there. We can further do this, but let's copy bunch of IPs from this. Let's say we are copying two IPs or three IPs. Sure, one second. We are capturing these IPs. Now, one of the things for this tool I wrote is it takes a single one IP per single line, and for this demo we'll just go with the four IPs. So we have this. We can run the tool. Okay. I forgot to do the when. Now it is installing the IP infos PyPy library, and we are running the tool. Error message, unknown error, I'm not sure. Okay, this is IP mapping, I think. This is another one of the features of this. We are using one single thread, and it took this minutes to complete. And now we can see like this IP info. This we can see like we got all the data from this, and heat map is somehow not working. So this heat map is something which will generate kind of mm, a heat map for the IP info. So quickly we will see this. So I'll quickly show you this in the GUI. You can try it on the tool. I also have to check whether something is broken with this. Mm, where is this? Mm, anyways, you can try out the tool. Let me know how it went. And moving back to the slides. So this is the tool. It will generate some of the things for the IP info DB, and also some of the other things where we can um, generate a heat map and see some of the things that are already available. Now, if you have any questions, feel free to ask. And this is the link for the tool, so you can see it and just figure some of the things out. Please share this log file and script link. I actually prefer not to share this log file because some of the sensitive data might be there. You can actually do something like this. You can capture data on your own traffic, like you can capture traffic on your own EC2 instances or VPC. Just leave it open for a few hours and just configure the flow logs. You will get it. The script is there. Script link is also on the screen, and you can simply use this script and figure some of the things out. Three-tier architecture setup. Mm, Sir, can you analyze the logs in this, and it can be used for the blue teams? Yes, it can be used for the blue teams, and it is mostly for the blue teams. So some of the other things you can do with this is, let's say if you're monitoring some of the things for the compliance sake, right? So it is also very valuable in that scenario, because in most of the compliance, if you go for the certifications like I think SOC 2 or like many of the certifications, they will ask you for the network um, diagrams, logs, how you're capturing, monitoring. So it is useful for the compliance purpose. One other purpose is, let's say you have let's take a scenario. So let's say you have a EC2 instance deployed somewhere. Let's say you have also monitored, and let's say you are also install some EDR agent on that particular machine. Now an attacker came into the machine, and let's say they disabled the EDR agent. They somehow disabled it. They somehow prevented the telemetry from being pushed to the server, the your EDR server. Now, in that case, we are obviously kind of blind, because we cannot see whatever is happening, and we have no other way to capture this sort of traffic. So, if we are capturing the traffic at the VPC level or the instance level, and if we are capturing these flow logs, so we can analyze from that. Let's say at 12, 1 they disable the EDR. Now a blue team can go fetch this data, this flow log, and then from there they can analyze. Okay, so this instance, whatever connections were made, whatever connections this instance made to the other IPs, or whatever connections were initiated for this instance. So you can check all of these things, and it is actually a very efficient solution that I personally think is, because we are capturing the passive traffic, and it is a very good amount of data. Although some of the things we cannot capture, like we cannot capture the exact packet bytes, like the payloads, but we are getting the metadata about the traffic, and it is very crucial when we are analyzing some sort of things where the EDR agent was disabled, or whether some crash happened, or whether something happened. So it is a good way to detect in that scenario. If the attacker does block the EDR, then we can use this analytes. Yes, in that case we can use, but this was just a kind of a scenario. Like that was a particular scenario, but this sort of data will be giving you a whole good insight. Because see, again, if we are installing monitoring agents and not talking about the EDR, let's say we are installing some sort of software on our instances, which is monitoring the ingress and egress traffic and mapping it somewhere, like publishing it somewhere. That agent is also consuming some resources, be it in the terms of storage or be it in terms of the memory. That could also get hectic if you are managing multiple instances. There could be scenarios where that particular agent, and agent by agent I mean the software which is monitoring the ingress egress connections, it can crash, something could happen. So in that case we won't get the data. But if you're capturing at this passive level and this high level, we get the traffic that is entering and traffic that is exiting from whatever boundary. And again, by boundary I mean the network interface level, or the subnet level, or the VPC level. So again, pivoting back to that, so that is kind of the goal of this, to have a passive data, passive log available when it is required. And here is something like someone told me a while back, and it is something that hit me hard. See, it is good to have something you don't need, rather than needing something but don't have it. So it is that kind of scenario, like where we might not need it at this moment, but there could be a time where we might require it. And if we require some sort of this sort of data, if we don't have it, that is kind of a bit troublesome. So yeah, three-tier architecture setup. Again, I'm not sure what this 3-tier architecture setup is. So, if you can explain, that would be very good. I guess we don't have any questions, so we will be ending the session. Thank you all for joining, and yeah, so thank you. Have a good day or night or whatever it is in your time zone. LinkedIn for what? I mean, do you need our company's LinkedIn, my LinkedIn, which LinkedIn? Because if you need our company's, it's already everything is on our website. You can also search for us on the LinkedIn via Cyber Warfare Labs. My LinkedIn, you can simply search me through our company's profile. If you go to the company and if you go to the Cyber Warfare Labs on LinkedIn, you can see um, in there will be a people section. In the people section you can find me under the name Abhijit. Also, if you want to search it, it's Abhijit, ABHIJEET dash SecOps, SECOPS. Again, I'll just post it in the message so you can anyone can check it. So this is the username. Just append www.linkedin.com/in or whatever they use, and just ping me there if you have any questions, or you can also mail us. And so yeah, so I'll be ending this session if we don't have any other questions, and it seems we don't. So okay, guys, have fun. Bye bye.